Hello everyone. In this video we're going to be looking at MinStack, which is LeetCode problem 155. So MinStack states that design a stack that supports push, pop, top, and retrieving the minimum element in constant time. So this is key right here. So implement the MinStack. MinStack initialize the stack object. We're going to have a push method that passes in a value and pushes that element onto the stack. And pop will remove the element, and top gets the top element of the stack, and this getMin method retrieves the minimum element in the stack. Now if you remember, a stack is like a stack of plates. So you put a plate on the bottom, and then the next plate goes on the top of that, and the next plate on top of that, and then when you pull them off, you pull the top plate off first. So here we have an input of MinStack, push, 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 get min, pop, top. And down here are the corresponding values. So it's probably I'll just go through the explanation, because basically MinStack here is corresponding with this empty array, push, push -2, push 0. So these, and the output, it's easier just to try and understand the explanation. So we're going to instantiate a MinStack, and we're going to push -2, and then we're going to push 0, and then we're going to push -3. So when we get the min, it should be -3. Now we're going to pop. So we're going to take the top value off, which is going to be the -3. So even though -3 was the min value, because it's the top value, we have to pop that off. And then MinStack top will then be the 0, and the get min will be -2. Alright, so let's look at how to do this. So we're going to be using two stacks here. We're going to have a stack that's going to keep track of all the numbers, and then we're going to have a short stack that keeps track of the minimum values, the minimum numbers that get passed in. So let's look at this push method first. So we're going to pass in an int. So if the short stack is empty, or the passed in value is less than or equal to the short stack peak, and short stack peak simply looks at the top value, the top plate on the stack, but it doesn't actually remove it or do anything with it. So if this value is less than what the short stack currently has, then we have to add that to the short stack. So we're going to push that on the short stack, and then we always add it to the stack. So the next method we're going to look at is the top method. So this is just going to peek at the top element on the stack. And so we'll just return a stack.peek. The next method we'll look at is the pop method. So this, we have to add a little more logic. So if the stack.peek, peek at the top number on the stack, equals the short stack peek. So if the last thing we add to the stack is also the last thing we add to the short stack, well, now we've got to pop that off of the short stack. And then we always pop stuff off the stack. Then finally, the getMin method is just going to return the short stack.peek, the top value on the stack. And then we end the method. And that is it. So let's run this through the debugger. So I just took the example that they had, LeetCode had. So the first thing we're going to do is instantiate a stack. And we'll instantiate, actually I called it min values here, and then we're going to push the -2. Let's go down to the push method. Min values is empty. It sure is. So we're just going to push that to the min stack. And then we're going to push it to the stack. And then we're going to push 0. Now, is 0 less than -2? Nope. So we're going to pass that, or we're not going to add it to the min values stack, but we are going to add it to the stack. And then we're going to push -3. Now, -3 is less than or equal to -2, which is the current number inside min values. And so we're going to push -3. And again, push it to the stack. Okay, so now we're going to get min. And that's just going to take the top value off of the min values. And so the result will be -3. Now we're going to pop off the top value. So stack.peak does in fact equal the min values.peak. So we have to pop that off of min values and then pop it off the stack. So now we just want the top value, which is just going to return stack.peak. So that will return 0. Yeah, result 0. And finally, we're going to try and get the min value, which is going to be the -2, because that's the only value that's left inside the min values stack. And that is pretty much it. So let's run this through LeetCode. Accepted. And submit that. Ooh, 27%. Let's try that again. 40%. Do I go for a third time? 74. I'll take it. Uses less than 82.22% of submission. So that's pretty good. And once again, the last thing we'll do is go through the space and time complexity. So time complexity is O of 1. That was what we had to do with LeetCode. And we're just pushing and popping numbers off stacks. We're not taking it doesn't take any more time to push and pop numbers off the stack. The space complexity is O of n. So as the stack can grow and shrink, the worst case would be just a ton of pushes. So that would need more space to handle a bigger stack. And that is it. So once again, thanks so much for watching. Let me know if you have questions, and we'll see you next time.